Hey guys, welcome to your notes for today. Today we're talking about dilations, and what that is, it's our last transformation we have to learn about, and it's our only transformation that changes the size or the shape of our original pre-image. So let's go ahead and take a look at it. First of all, make sure you understand translations, reflections, and rotations before you move on to this lesson. So let's go ahead and get started on what dilations are. So a dilation is a transformation that enlarges or reduces a figure by some sort of scale factor relative to a center point. That point is called the center of dilation. And for all of your examples, our center of dilation is always going to be the origin. It's always going to be 0, so you don't really have to worry about it, but make sure you understand that our center of dilation is always our origin, at least for the problems that you will do this year. You've seen the word scale factor before when you were looking at, when we did some 7th grade math on ratios and proportions. So scale factor should be kind of familiar to you, and we'll talk about that at the very end of this lesson. So in mathematical terminology, a dilation is the scale factor. We're always going to use k as our scale factor. We use k as the scale factor just as our variable. So k is going to be equal to your scale factor. Again, I apologize for poor handwriting. I do not have my online virtual pen, so this is all by mouse. So if it looks sloppy, that's why. But an enlargement is going to be any sort of dilation that k is bigger than 1. So if k is bigger than 1, then your object is going to increase in size. It's going to get bigger. But if k is less than 1, and it makes sense that k cannot be 0, because if k is 0, if we have a scale factor of 0, well then our shape's going to disappear. So it has to be greater than 0. But also, if it's less than 1, if it's a fraction or a decimal or something like that, then our shape is going to get smaller, because we are looking at a fractional percentage of the actual of our pre-image. And if we have a k of 1, of course our shape is just not going to change, because we're just going to be multiplying by 1. When I say multiply, I'll talk about that here in a second. But when you see the center of dilation and the coordinate plane as the origin, each coordinate of the pre-image is multiplied by the scale factor k to find the coordinates of the image. So this is actually a fairly easy transformation to do. So when you have a point of x, y, you're just going to take whatever your scale factor is, whatever they give you as the scale factor, or whatever you find to be the scale factor, and you're just going to multiply it by your original points. So you're going to have k times x, and you'll have k times y. And that's all the calculations you have to do. So you see a here is at 1, 1, and they got a prime at 2, 2. So they must have done a scale factor of 2, so they multiplied x by 2, y by 2, and got 2, 2. So this is 2 times larger than this original pre-image. So let's go ahead and take a look at a couple of examples of this. So this says a triangle has the vertices of 0, 0, b, 8, 0, and c, 3, negative 2. Find the coordinates of the triangle after a dilation with a scale factor of 4. So keeping in mind this rule, and I'm not going to graph it on here, mostly because I don't have an x up to what this 8 is going to be. You'll see in a second. But we have to find the vertices of a prime, b prime, and c prime. So our scale factor is of 4, so that means we're going to have to multiply each of these by, take a wild guess, what do you think we're going to have to multiply both our x and y by? Well, of course, we're going to have to multiply it by our scale factor of 4. So 0 times 4 is still 0, 0 times 4 is still 0. So a prime is going to stay at 0. Stay at our origin. But take a look at what happens to b here. Instead of being 8 points away on our x, it's going to be 8 times 4 gives you 32. So this is going to be a much larger triangle after our our image is going to be a much larger triangle than our pre-image. C times 4, 3 is 12. And that negative 2 times 4 gives you negative 8. So you're still going to be following the same integer rules. Negative times a negative is a positive. Positive times a negative is a negative. And all of that good stuff. So this would be your answer to this problem. Notice in this problem, I didn't even need a graph. I didn't even need a coordinate plane. But sometimes you will have to have a coordinate plane. So this says a figure of vertices of W is negative 2, 4. X is 1, 4, Y is 3, negative 1, Z is negative 3, negative 1. Find the coordinates of the figure after dilation with a scale factor of 2. And I'll actually be graphing this one, so go ahead and pause the video, try to solve this, and try to graph it just to make sure you're graphing points correctly. So you can see here I've graphed our original pre-image, our vertices W, X, Y, and Z. So let's go ahead and graph the image after our scale factor of 2. So W, that negative 2 is going to become a negative 4, and that 4 is going to become an 8. So we'd be at negative 4, positive 8 for W now. Then at X, 1, 4, we're going to be at 2, and then that 4 again is going to turn into that 8. So we have X up here. Then we have Y, which will be at that 6, and then negative 1 times 2 is just at negative 2. So that's Y. And then Z is at negative 3 times 2 would be negative 6, and negative 1 would again be that negative 2. So we'll have Z right here. And we'll notice what happens to our shape here. So talking in broad terms of our shape doesn't change. Our trapezoid remains a trapezoid. However, the size of our shape changes. So that's important to remember, that our size changes, but our shape stays the same. And of course, make sure you know how to graph. So let's go ahead and take a look at another example where we're going to be graphing again. Only this time our scale factor changes a little bit. Our scale factor now is at 1/2. It says a figure with vertices of J 3, 8, K 10, 6, and L 8, 2. Graph the figure and the image of the figure after dilation with a scale factor of 1/2. So go ahead and pause the video and try to graph this. Try to guess what you think is going to happen to our shape here when we have a scale factor that is less than 1. So go ahead and graph those points, pause the video, and we'll move on here in a minute. So here we have graphed the pre-image of JKL, and we see that makes us a triangle, and any 3 points is going to make us a triangle. So let's go ahead and apply our scale factor of 1/2. So I'm just going to go through and apply it to each of these points. So for J, I'm going to have to multiply 1/2 times 3. Well, that gives me a decimal, 1.5. So I'm going to go in between this 1 and 2 and go to 1.5 on my X, because the 3 is my X value. And then I'm going to have to move by some sort of Y, but I need to multiply that 8 by 1/2. I know that half of 8 is 4, so I'll go over 1 and 1/2, which is half of 3, and go up 4, and that is where our new J point, J prime, is. For K, half of 10 is 5, half of 6 is 3, so we have 5, 3, and that is K prime. Don't forget your prime notation. I think I forgot that on the first example. L, we have 8, 2, so half of 8 is 4, half of 2 is 1, so L is right here. L. And then we draw our shape, and we notice we get a triangle that is half the size of our original pre-image of JKL. Don't forget your prime notation again, and make sure you could write down the points of J prime, K prime, and L prime. So let's go ahead and take a look at our last types of examples where we're actually calculating the scale factor instead of graphing the points based on the scale factor. So we have through a microscope the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25 millimeters. What is the scale factor of the dilation? So how you can find scale factor is actually through ratio. And you've actually done this before in 7th grade, but this is just a new way of looking at it. So what you're going to do here is you're going to take the image distance. So here our pre-image is that 0.25. And we're going to take that 11.25 or that image distance. Or if this was a point, it would be the prime distance. It's after our dilation. And we're going to have to divide it by our pre-image distance, which is in this case 0.25. So when I take 11.25 and I divide it by 0.25, that means I get 45, which means our scale factor is 45, and that would be 45 times larger. And that makes sense, right? 45 times larger makes sense for looking at a very small thing underneath a microscope. Notice if we accidentally did it the wrong direction and we did 0.25 divided by 11.25, we'd get 0.02 repeating. If I'm looking through a microscope and that's making my object smaller, that microscope isn't working like it should. So make sure your answer makes sense, and this 45 times larger does make sense. Here we have two different ways of solving the problem. Lucas wants to enlarge a 3 by 5 photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? So here you have to figure out, does the 3 go with the 7.5, or the 5 go with the 7.5, or does 5 go with 12.5? You have to find out which numbers go with which. So if you're talking about photographs, normally you talk about 3 by 5. And then they say they want to turn it into a 7.5 by 12.5. So notice that this 3 goes with that 7.5, and that this 5 goes with this 12.5. So you have to make sure that you keep, because you have to keep this length is the same as that one. Not same, but they correlate. They correspond with one another. And this width or length here corresponds with the 5 corresponds with 12. What that means is I can take 7.5 divided by 3, or I could take 12.5 divided by 5. Each should give us the same scale factor. So let's make sure it does. So 7.5 divided by 3 gives me a 2.5 as our scale factor. And if I do 12.5 divided by 5, look at that, I get the same scale factor of 2.5. Which makes sense because we're enlarging a photo, so our K, or our scale factor, needs to be larger than 1. Now, if we get a scale factor that is less than 1 but greater than 0, so a fraction or a decimal, that means we'll be doing a reduction instead of an enlargement. Hopefully that all makes sense. If you have any questions, please send me an email. I hope to see you all soon, and I'll see you all later. Bye.